or the other thing?
is doing?
Thing is doing?
I think. I hope.
You got much closer to your mic.
Whoa. Well, people always say I'm always too quiet. So I'm just going to be really close to my microphone now.
That was an amazing radio voice. You could totally do
Is
the
that
movie guy that way.
is that the way I should only talk from here on out?
That would
I'm
probably
I'm
hurt your
I'm
vocal
Fraser
cords.
Cain. Welcome to Astronomy Cast. Yeah, you like that?
Oh my gosh, the two of us could do something that would not be safe for
Did I
work
mention
with
that
our
we're live?
voices.
Did I mention that we're live,
Yeah.
Pamela? All right.
Yes, I'm still yeah.
Okay, I am going to say hello to a bunch of people. Whoop, no, wait. I broke it. Hold on.
What did you break?
Hello to Abraham Cottrell, Adam Synergy, Amanda Peltier, Bill K, Capital H, Carolyn B, Charles White, Chris Adams, Coffee Singularity, Douglas Crandall, Urswell Notions, Esther Gagne, Frank Tippin, Gordon Dewis, Enoch, Guido Bibra, Harry Patrick, Helg Bjorkog, John Seffield, Lillian Brennan, Linda Sadik, Mokopa, Mr. Tom Harbin, Nancy Graziano, Nichols of the Yard, Parano 001, Paul Smith, Peter Quinn, Rinstro, Richie Selfridge, Rick Schwartz, Ribe, Umu, Zapfan, and I forget, was it Jacob? The 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 name
Oh,
in
the Hebrew one,
Hebrew
yeah, it
one,
was
yeah,
Jacob. Or probably Jacob.
Jacob. And um, before we get into this week's show, I'm trying to think. This goes out Monday morning, so I could probably do an announcement in the podcast for what I'm doing on Monday.
Yes, yes, you could. And I'm noticing looking, I look much taller than you do, Mr. I'm crumpled down. I
All
don't know
right.
if you can adjust that on your end. If not, I'll adjust my camera.
No, you're like a director. Sure, I can move it.
I
I can.
just know that in reality, you're
No,
like a
you
foot
are.
taller than I
Yeah,
am.
no, your camera is absolutely sort of right to the top of your screen, so there's no
This is so I
room.
can talk with my
Sure, so then
hands.
don't worry about it. Don't worry about it. Hey, let me handle the directing, and
This
you
is
just
what
worry about
happens
the
when I go to
sides.
get the pop out chat. I
And
see
you
these
have
things.
been too much of like a host now.
It's true.
Yeah.
It's true. I'm getting good at this.
I know. I know. Turns out you just practice something a whole bunch of times and you get really good at it.
Go figure. Well, it doesn't work for spelling. I'm just going to say that.
No.
No.
But yeah, but that's why we have
Spell check.
spell check. Yeah. So how did you like that? Did you see the Google I/O? Did you see
I
the
have not
duplex
yet. I
service?
have not yet. It's on my list. It's been that week where you kind of feel like you got a lot done and kind of feel like you got absolutely nothing done, but do know that you didn't like watch anything.
Uh, Pernicious Knid says posture is important for people our age. Fraser, I know. It's not about my posture. It is about
It's literally the camera
it's the
angle.
camera angle, yeah,
Yeah.
or posture. All right, let's. Now we've got to do a shorter show because I've got to take a kid back to school. I pulled Chloe out of her school so that we could get her passport updated, and unfortunately, to get her passport updated, she needed another kind of ID. She needed her driver's license, so we had to go get her
Oh,
driver's license test, and then hopefully we can get the driver's license turned around, and then we can get her passport turned around.
wait. How did people who can't drive get
You
passports?
can get another thing in British Columbia called your BC ID, and it's like your driver's license, but it's just an ID.
Okay.
Yeah, so we can do that, but
Okay.
she should get her driver's license anyway. So and she'd been kind of putting it off, and so this was like now we have to get it done. So that was my whole morning, and now I'm not done yet. I got to take the poor kid to school, or she'll fail. So I don't think she'll fail.
No.
All right, let us begin this show that we're going to do.
Yes.
Tell me
Let
when you're
us.
ready.
Oh crap, I forgot to open Audacity. Sorry for the swears. Oi. All the weird error messages. Okay, now
Ready?
I am ready. I am pressing record.
I am also pressing record.
It
All
is
right,
very exciting.
here we go. Astronomy Cast, episode 491, Exoplanet Update. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. I have a fun announcement, which is I don't know if you know, I've been doing over on my regular YouTube channel, I've been doing sort of an open QA, bringing in a special guest every week. One of those guests will eventually be you. But this week, the next week is going to be Dr. Alan Stern and Dr. David Grinspoon, who are the creators of the new Pluto book about New Horizons, and they're going to join me for a live QA on the channel. So that's on.
Please tell me you have Michael Brown scheduled for
I
sometime a few weeks from now.
no, but I totally can. So I've done a
Me
live stream
too.
chats with him a bunch of times. So yeah, no, I will totally try to get the other side of the story. We obviously can never put them in the same room, but
No.
yeah. So it's going to be last minute. So if you're getting this, you're listening to this on Monday morning. The live stream is going to happen Monday afternoon on my YouTube channel, 5 p.m. Pacific. And I will also put it out onto my podcast feed. So if you want, you can always listen to that on the YouTube feed. So join us live. Ask your questions of Dr. Stern and Dr. Funky Spoon, and we're going to have a really good time. All right, let's get on with the show. So finally, a big update. Has there been news in the realm of exoplanets? More news than we can possibly cover, but we will try our best. This feels good. We got like news for days today.
It's true. And so I started a new Twitch series where I'm just doing 15-minute update on the news every day at noon local, which is 1 Eastern, 11 Pacific. And there's not a day where there isn't an exoplanet story. Like, not just an exoplanet paper coming out, but something worth covering in the news and bringing to mainstream attention. Our understanding of other solar systems has gone from they exist, which is pretty much where we were last time we had this
Yep.
conversation, to let me detail all the ways they exist for you. And wow,
So do you know off the top of your head how many planets there are right now? Confirmed exoplanets?
there are 2,950.
Are you sure?
That is what they have at exoplanets.org, which is my go to for this kind of thing.
I will even say, are you sure? Because it was like 3,700 when I looked there fairly recently. I think the
So,
exoplanets.org is older. Yeah.
oh, really?
Yeah.
Dang it.
The exoplanets finder. I forget the name. The one that Dr. Jesse Christensen is with is like the exoplanets database, and I think they're at 3,700.
There, we can't even keep the
Yeah. The
databases up
Exoplanets
to date.
Archive has 3,725 confirmed planets as of April 26, 2018. And
I need to update my go to
yeah,
source.
so there you go. Yeah, do the Exoplanet Archive. And then there are an additional 4,496 Kepler candidates. So there are probably 10,000 possible planets in the works that they're looking for, as well as
And
confirmed planets. It's crazy.
what gets me is how no one can keep any of these websites up to date. I pulled up NASA's website on Kepler, and NASA's website for Kepler says that there are 2,244 exoplanet candidates from Kepler, and then another 480 from the K2 mission. And so nothing is up to date, apparently, except for the NASA Exoplanet Archive,
Yes.
because we're finding these suckers so
Yeah,
quickly.
and so that's the thing is just like every single day there are a couple of new planet announcements, new planet conversations from a range of different planet hunting telescopes, ground based, space based. It's it's mind bending. And this is like so 10 years ago we did
Yeah.
really know of a handful. I'm sure it was in the hundreds
And
at the
and
most.
part of what's allowed this to happen is all the new telescopes we have. So the first time we had a show on exoplanets was prior to Kepler's launch. And it was prior to the Atacama Large Millimeter Array, ALMA, getting commissioned and beginning to take data. And we just keep creating new and interesting ways to find exoplanets. And now we have tests launched and on its way out to its final orbit. And it's another way we're going to be finding exoplanets. And as we increase the methods that we're using to find worlds, we are finding more and
Yeah.
more worlds. It's just that simple.
Well, so the Gaia mission,
Yeah.
right? So it's expected to turn up by 2020 10,000 to 50,000 planetary candidates.
Oh, jeez.
Right? Like it's crazy. And then of course Tess is going to turn up tens of thousands as well as hundreds and hundreds of Earth-like worlds in the habitable zone of their star. So there are too many individual interesting planets for us to talk about. So let's
Yes.
just talk about the sort of large
Where they come
scale.
from.
Yeah, let's talk
And
about some of the interesting variations that have been found, how some of the kinds of planets that are being found make our solar system look weirder and weirder as an outlier. So let's start at some of the kinds of interesting planets that have been discovered.
so it's so hard to know where to begin. Um, so we keep finding new pulsar planets. These are planets that are found by looking at the timing of pulsars, which should be more accurate than like your everyday atomic clock, except if they have a planet going around them, their timing gets thrown off in a systematic way as the stars pull back and forth. And so we find our tiniest things. These are things that are just fractions of the size of the Earth around these pulsars. So that's cool. But then when we start looking at what is the smallest planet that's been found around a like normal everyday star, here we're finding an object that is half the mass of the Earth, half the radius of the Earth, and the lowest density thing we've ever found. So it turns out that the smallest planet going around something that isn't a dead star uh, is weird. It's basically a gas giant like in its physics, but smaller than Earth in its mass. And this is a combination we did not know to expect.
Right. So that's weird.
Yes. So we have those. We keep finding these hot Jupiters, these objects that are, well, we found one that is 30 plus or minus 15 times the mass of Jupiter. There's a chance that this is actually a brown dwarf, but if it's not, it is a planet going around HR 2562. Bad names. We have lots of those. And this this planet is like bigger than we kind of expected would happen. Other weird stuff. Scott Gaddy and his team at Ohio State realized everyone and their sibling is currently looking for a planet around a red dwarf star because, well, red dwarfs have not a lot of mass, so they're easy to yank around. And they tend to have their planets snuggled up close, so transits are easy to detect. And since everyone and their sibling is looking for planets around small stars, he decided to look for planets around giant stars. And they're finding planets around giant stars, which is somewhere else we didn't think we would find planets. So all these places were like, meh, won't find a planet there. Yes, there are planets there.
And so one of the things that's very interesting as well is the discovery of some some entirely new classifications. You mentioned things around pulsars, the hot Jupiters, which were the first planets that were ever really found, apart from the pulsar planets. But there's this whole classification of planets that are in between the size of the ice giants and
Mm-hmm.
terrestrial planets that we have here on Earth. So can we talk a bit about super Earths and sub Neptunes?
Yeah, so they're there. We're so the test mission is going to revolutionize our understanding of these weirdos. One of the problems that we struggle with Kepler is it is looking for planets through a cone of space. And the reason I say cone is it's pointed at a single field. And that single rectangle in the sky represents a very small physical area nearby and a larger and larger area as we look further and further out in space, which means that if you add all of these areas together, sum them, if you will, and integrate, you end up with this cone shaped volume. And since they're looking at a larger volume of space further away, we're finding a lot more planets around stars that are further away with Kepler. And these more distant objects are a lot harder to follow up on. It's a lot harder to get high resolution spectroscopy that allows us to measure what are the different atoms and molecules in these planets' atmospheres. Now, with Tess is going to be looking at everything nearby and just kind of pointing all over the place. And as it points at star after star after star, we're going to start finding these weirdo intermediate objects multiple times close enough that we can point big Earth based telescopes at them, like the Very Large Telescope down in Chile. And this will allow us to measure what's up in their atmospheres, allowing us to finally get a handle on how. Sometimes you just look at planetary science and that's the best you can do is how. And anyone who tells you they know how planets form in a detailed manner is lying.
So just sort of kind of trying to envision what one of these, say, super Earths would look like. If we could see one up close, what would we see?
Where it gets tricky is these super Earths come in a variety of different temperatures because they're orbiting stars of different temperatures
Mm-hmm.
and they're orbiting at different distances. What you see is a function of temperature. If you think about it, Saturn, Jupiter, very, very similar compositions, look radically different because they have different amounts of incident sunlight. And then Jupiter, just to make things interesting, is still spilling energy from its core. This added heat changes the thermodynamics of the atmosphere. When we look at Neptune and Uranus, very, very similar objects, we see differences in their storm patterns based on differences in the thermal gradient because Uranus is tipped over on its side. Depending on where these big Earths, small ice giants, are located, we're going to see different colored atmospheres, but that's going to be the dominant thing we see. These are probably objects that have rocky cores. Some of them we're finding out are like solid water on the surface. And it's no one thing. So it's all going to come down to what does the thermodynamics of this object allow it to do? What does the thermodynamics of this object allow it to do? And we're going to have to build up a continuum. Mercury, Mars, Earth, these are all terrestrial worlds. Venus, terrestrial world. Can you ask me what do terrestrial planets look like and have me answer one thing?
Mm-hmm.
No.
Yeah.
This is that exact same problem. So we're looking at objects that are going to be dominated by something on top of rock, whether they're cold enough to be flooded in water, whether they're hot enough to have a massive bloated out atmosphere with a huge mass that's increasing their total mass. I can't tell you. They're going to have a variety of characteristics, and they are all going to be awesome, as every world is.
Right. And many of them seem like they're going to have large amounts of water on them, could very well be water worlds
Yes.
with, with kilometer thick ocean across the entire planet, and then you get to,
Rock.
the rock.
Yeah.
This idea of these sub-Neptunes, so something that is maybe half the mass of Neptune.
Mm-hmm.
Is it made of ice? Is it made of rock? Let's talk a bit about the kinds of observations now that astronomers are able to do. One of the things, again, 10 years ago, really about 10 years ago, we did our, again, we went after the low-hanging fruit. We went after hot Jupiters and other planets, is being able to make atmospheric measurements. So a lot of the infrared telescopes
Yeah.
now are able to observe their atmospheres, which is,
Yes.
again, just mind-bending. So we talk a bit about that.
And what's so the ways that we're finding planets today range from purposeful to there's a planet. And I just love the fact that we're now accidentally finding planets. Just like when we had this first conversation, you can find planets by looking at bright stars using high resolution spectrographs and looking for the little tiny motions that are indicative of a planet slowly moving its star around the mutual center of mass. And the amount of motion that we're seeing, you could run faster than these stars are moving. So it's not a huge movement. And this is where you need bright stars that we can really spread their light out. We can make really accurate measurements of what's called the radial velocities, the rate at which the star is moving towards us and away from us. Now, in order to find planets using the radial velocity method, you need to have a planet that is passing between us and the star. It can be a little higher, a little lower than the star. So, this method allows you to find stars that are transiting and that would transit if only they were closer to their star or their angle was tilted just a little bit more. It does not let us find the planets that are going around the star in the plane of the sky relative to us.
Yeah, we're only able to detect with all of our methods just a couple of percent of the planets that are out there. They have to be lined up.
And Gaia is going to help get this better. But even then, it's going to be limited on the size of the planets and how quickly it can find them. So we have the radial velocity that uses ground-based telescopes, large spectrographs, and can only really work with bright stars. The other method that we have is looking for transiting planets. This is when a planet passes in front of its star, causing the star's light to dim slightly. This is something that you can do with a backyard telescope if your backyard happens to have really good sky conditions. What you need is the perfect sky that isn't fluctuating and twinkling all over the place, and really, really, really well calibrated equipment. You don't need big equipment, you need well calibrated equipment so you can look for that fraction of a percent dip in the star's light. This is the method that Kepler uses. This is the method that K2 used. This is what TESS is going to be using. Now, in addition to these two methods, which again are super sensitive to stuff where the planet is between us and the star, we also have microlensing. And microlensing does not care what the orientation of the system is, as long as at the moment the microlensing occurs, the planet is neither behind or in front of the star. So in this case, we have some background star that passes as it orbits behind some other solar system. And what we're doing when we look for lensing is we're looking for faint, otherwise unobserved stars and, well, the solar systems that travel with them. We're trying to identify where is all the unidentified stuff in our galaxy and in other nearby galaxies. Teams like the Macho team have gone out, done the microlensing, and every once in a while, you'll see a background object get lensed, get its light magnified by bending light that otherwise wouldn't get to us toward us by some intervening star. And if we're lucky, by a planet, and sometimes that planet's moon, as they all move past one another in the sky. This is the only way we have so far definitively detect, well, as definitively as you can do anything that you can't reproduce in science. This is the only way that we've gotten fairly clear evidence of moons
Right.
around alien planets. And
Which is still
that's kind of
crazy.
awesome.
Yeah,
Yeah.
moons around planets orbiting other stars detected. And
Yeah.
actually, this is one of the fields where amateurs with reasonably small telescopes are able to
Mm-hmm.
make meaningful contributions. Whenever there's one of these microlensing events, you can get an alert. You can point your telescope at the sky. You can point your telescope, gather the light, and submit your data, and the astronomers are able to use that. And in some cases, amateurs have discovered microlensing planets. The problem, of course, is that you only get one shot at it, and then it
Yes.
never happens again, which is sad.
So, yeah, so we can't like confirm any of our results other than seeing the same thing at multiple telescopes, which is why we do get so many amateur astronomers involved. It's easier to get 10 people to get the telescope that they own all pointed at the same object than to get 10 nationally or internationally administrated telescopes to all point at the same object.
And I think the thing that's happening now that's, you know, as as many planets that have been found already, we're right around the corner. We mentioned Gaia. A couple of years we're going to find out the Gaia information. But the European Southern Observatory has been building a bunch of really special instruments and attaching them to their gigantic telescopes and the future telescopes that are coming, and things like they've got the most sensitive coronagraph that's ever been built here on Earth that's going to be able to block the light from the star and be able to reveal the planets around the star. I forget the name of it. Darkness, I think, is the name of the
I can't
instrument.
keep
Yeah, and
up.
they've got the espresso, which is going to be this sort of interferometry from this huge spectrometer that's going to be connected to all of these observatories. And then there's the Large Synoptic Survey Telescope, which is going to be able to find theoretically planets. And so there are so many amazing instruments now coming up that it feels like we're going to go through another order of magnitude. Like in
Yeah.
each one, it's like this doubling that's happening. We're like, oh, now there's millions of known planets, billions eventually. We
Yeah.
are, just hang on, more coming.
It's absolutely amazing. And this is where it starts to get us to the way that I most didn't expect to see us finding planets already. And this is by direct imaging of them. There's a press release that actually came out earlier this week from the good folks over in the Netherlands. Christian Genske at Leiden Observatory and his team were studying the binary star CS Cha. And they just randomly, while using the Very Large Telescope's sphere instrument, um, trying to study this binary star, trying to study the dust disk around it, because these are two stars that are still in the process of forming and coming together and clearing out their disk. I There's this little spud out in the edge of the image that they looked at it in multiple ways, multiple times. The little spud stayed there, and what they think is this is a toddler planet, a planet that still hasn't fully developed into like what it's going to be someday. It's probably still growing, probably still gathering dust. And they directly imaged a planet by accident.
Yeah. Well, and so I think another thing that's very useful to talk about a bit is just like, again, it's been so long since we really talked about exoplanets that the TRAPPIST-1 system, which we found information about that last year. They are finding Earth-sized worlds within the habitable zone of red dwarf stars.
Yeah,
So
yeah. So, according to NASA, which means that this number could be out of date, because I'm looking on a NASA website, and it's hard to keep these websites up to date. Uh, Last this website was updated, Kepler alone had found 30 exoplanets less than twice the size of the Earth that were located in habitable zones, by which I mean that area around a star where the temperature allows, if the atmosphere of the planet is right, for water to exist on the planet in ice, liquid, and gas. It's at the triple point of water. And now we have Mars also theoretically in the habitable zone, Venus, but these two worlds have chosen very different paths toward becoming not good places to live. Venus kept all of its atmosphere, said mine, 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 and then made it poisonous. Mars was like, be free, atmosphere. It left its atmosphere go away. And without an atmosphere, it also like lost all of its water and things like that above the surface. There's water locked down in the surface. So both these worlds chose different paths towards non-habitability while existing at some place that, given the correct atmosphere, given the correct magnetic field, these worlds receive just the right amount of sunlight that they could have regions at this triple point of water.
Uh, but of course, these stars. I mean, it's really exciting, but it's thought that the planets are going to be tidally locked to their star. That, and so I'm just going to move on to one other super interesting. Well, it'll connect. You'll see, but they've found a planet around Proxima Centauri, which is the closest
Yes.
star to
Us.
us, except that Proxima Centauri sucks.
Yeah. Yeah.
It's a flare star.
Yeah. So if you watched the recent Netflix drop of Lost in Space, in this case you have a planet that's going around a binary system that's a normal star and a black hole, and the planet goes through a special form of death once per orbit, and then regrows everything. And so, in looking at the trees had a single growth ring. The animals all had to basically come into existence from shutdown states. So every animal, no matter what it was, had to go through that whole tardigrade. Let's hold ourselves up so we can survive the duration and then come back out. And anything existing on one of these crazy flare stars would have to have this capacity to go, oh no, the atmosphere, it's being ionized again. I must exist and endure until we have a happy atmosphere again. And who knows how that happens. And yeah, probably not good for life unless you're written by a fiction author.
So place your bets. 10 years from now, when we're still doing Astronomy Cast, do you think we will have found that holy grail? Will we have found that Earth-sized world orbiting a sun-like star in the habitable zone?
So
Will we have directly imaged with the James Webb Space Telescope the atmosphere of an Earth-sized world orbiting a sun-like star in the habitable zone?
well, I don't know what the probability of one being close enough to be able to do stuff like that is. What I think what I'm more willing to say is I am confident that in the next 10 years, we will find a world that has an Earth like surface gravity. So, that combination of density and radius that allows the surface of the planet to have the kinds of geologies that we see that allows life to walk around without either floating away or getting squished. I'm confident to say we will find a rocky world with a Earth-like surface gravity that is appropriately placed around its star, whatever its star may be, that it can have a rotation period, that it can be at the triple point of water, and that we will have used something to image the atmospheric variations that are indicative of clouds being there.
Uh, a discovery that was made just earlier this week. They found an exoplanet that has no clouds.
Yes, the sulfur atmosphere,
Yeah,
that was
yeah,
fabulous.
yeah. It's amazing. All right, well, 10 years. I will write this down. We'll see you around episode 1000 and see if that's the case. All right, thanks, Pamela.
Thank you, Fraser.
Stop
And now
that.
we save.
I can totally tell that you are doing these news updates now. So funny.
It's one of the reasons I'm doing them is to force myself to read the Astro PH
Yeah.
mail dump every day
Yeah.
and to read my press releases every day.
Yeah. Your knowledge of the current space news is,
Spiked.
yeah, has definitely spiked.
Yeah. Um, yeah. So between Fraser and I, we are soon to have a show pretty much every single day for you guys in
Yeah.
one form or another. So my daily space is just 15 minutes. It's a quick wind through of everything that's going on. I'm doing it on Twitch. Susie, awesome Susie, who we love, Susie, give Susie all the love. She does thankless work. She's moving everything over to YouTube so you can follow it
Oh,
on the
great.
and then I'm doing learning space. I still owe you your recording.
Hmm.
Um, and that's on Thursdays. You have the weekly space hangout on Wednesdays. You're starting virtual star parties up
Hmm.
using
Probably
robotic
Sunday. Yeah,
telescopes.
probably Sundays.
Yeah. And so we're working to do
Hmm.
everything we can so that you can like binge on space.
Binge on space. Space binge.
This is 491.
Yep.
Okay.
And like I said, I've got to wrap things up. So I
Yes.
apologize to everybody who had a bunch of really great questions. I'm sorry.
And I'm hosting Patreon office hours on Sunday. Check your email and I will work to answer as many questions as I can then. And for any of you wondering if I'm going to be, as a hobby, doing any painting this weekend, I'm going to a bachelorette party tomorrow. So I will be painting on Sunday. All of
Okay.
this will get
Sounds
announced
good.
tonight. You run,
All right.
passport your daughter.
All right. We'll see you later, everybody. Next
Bye
week.
bye.